Hello everyone, this is Pre-Cal Lecture 5.4. So what you're going to need for this lecture is your 5.4 note sheet and also have your unit circle handy. Alright, so we're going to literally draw out the graphs of sine and cosine in this lecture. And just a few bullet points before we start drawing. The cosine graph is shifted pi over 2 units from the sine graph. Okay, so y equals cosine x, which is this one we're going to draw. Just sine goes through the origin and cosine doesn't go through the origin. Now, after we talk next chapter about phase shifts and things like that, then that won't really be the case anymore. But at least for this chapter, the way you tell the difference between sine and cosine is the sine graph will go through the origin. The amplitude is the height of the function, and the period is the distance from max to max or min to min. So a period is just one cycle of the wave. All right, so on your sheet, okay, so this is my filled out note sheet. So leave some space on the left to draw the graph, and on the right we're going to plot the points, all right, and have your unit circle handy. So first of all, we're going to graph y is equal to sine x. All right, so let's plot over on the right side. We'll plot the points. Okay, so the x values that I'm going to pick, I'm going to show you how I pick those in just a few minutes. But for now, we're just going to pick really the famous parts from the unit circle. We're going to pick 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. Okay, so x is 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we're just going to plug those numbers in. When x is 0, so what is the sine of 0? So remember, on your unit circle, sine is the second value. Cosine is 1 at 0 radians, and then sine would be 0. At pi over 2, you can see sine is 1. At pi, sine goes back to 0. At 3 pi over 2, sine, the second value, is -1. And then back to 2 pi, which is the same as 0, we hit 0 again. So to graph this, we'll mark our x values. Now, the maximum we get up to is 1. The minimum is -1. And we'll mark pi over 2, pi, 3 pi over 2, and 2 pi. So just going to plot the points. So we've got a point at 0, 0, pi over 2, 1. We'll come back to 0 when we hit pi, then -1, and then back to 2 pi. So if we connect these dots, we get this nice, what we call a sine wave. All right, and that goes on forever in both directions. Okay, so the amplitude of this would be the height, and it's the height from the center, not the height from bottom to top, but the height from the center to the top, and that is 1. All right. The maximum, well, we're talking about the maximum what is the point at which the maximum occurs? Well, the maximum is 1, and so the x value is pi over 2, and the y value is 1. So that's where you have a maximum. The minimum, now you can write all this down underneath where you did your graph, or anywhere where you have some space. The minimum occurs at the x value 3 pi over 2. And that minimum value is -1, so we call that a min. The period is the length of one cycle. Okay, so we start at 0, and the whole thing starts over again at 2 pi. It goes up, goes down, so the period is 2 pi. And then the zeros occur at 0, pi, and 2 pi. So these are the x values where the zeros occur. Right? We could do those as points, right? It'd be 0, 0, pi 0, 2 pi 0. Okay? All right, so that's the graph of y is equal to cosine x. We're going to do the same, sine x. We're going to do the same thing for cosine x. So pause the video if you need to. All right, we're going to plot that cosine graph. I'm going to pick those same famous points on the unit circle. All right, 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, what is the value of cosine at 0 radians? Well, it's 1. Remember, cosine goes first. The way I remember it's cosine and sine is it's alphabetical. All right, C comes before S. So that's 1. At pi over 2, cosine is 0. At pi, cosine is -1. 3 pi over 2, we're back to 0. And then at 2 pi, we are back to 1. So the cosine graph, instead of going through the origin, all right, it starts up on the y-axis. So we've got pi over 2, pi, 3 pi over 2, and then we come back around to 2 pi. So we start up here at the point 0, 1, right? This is 0. And then we have a 0, the y value is 0 at pi over 2, -1 at pi, 0 at 3 pi over 2, and then we're back to 1. So this is one complete period, one cycle of this cosine wave. All right, and then the whole thing just repeats. Okay, so we have let's go through those 5 questions that we have there. First of all, our amplitude is just the height, so the amplitude is 1. We have a max at the point 0, 1. The x value is 0, y value is 1. Okay, and then we have another one, if you wanted to call that, at 2 pi and 1. We've got a min. All right, where are we minimum? We're at the point pi -1. Sometimes for max and min, you're just asked for the y value. What is the max? Well, the max is 1. What is the min? The min is -1. It's the y value they're asking for. I'm giving you the points here. Our period, what is the distance, the x distance for one complete cycle? We start here, we finish here. Well, it's 2 pi. I'm going to show you how to calculate that in just a minute. And then our zeros occur at pi over 2 and 3 pi over 2. All right, so pause the video if you need to, and we'll make some changes to these graphs and see how things move. All right, the next one. Okay, so before we do another graph, let me go over these notes at the top of page 2, and I want to show you a couple of mistakes, or certainly one mistake that's on the notes. So if we have this form, y is equal to a sine bx. Okay, these numbers in front, a and b, those are important. Or y is equal to a cosine bx. So we're changing those original y equals sine x. We're putting a couple of numbers, one in front and then one in within the angle, okay, as a coefficient of x. The amplitude, you can see on your notes, is the absolute value of a. So even if that number were negative, then you would take the absolute value of that. The amplitude is always going to be a positive number. Then whether it's positive or negative tells you where it starts on the x or y axis. Now here's where I have a mistake. The period, so correct this on your paper. The period is 2 pi over the absolute value of b. I accidentally on your notes put the absolute value of 2 pi. And of course that's going to be, 6.28 and, on forever. And that's going to be a positive number, the absolute value of b. So please correct that on your paper. All right, so now we will graph 3 more functions. So the first one is y is equal to 2 sine x. Okay. So the way that I figure out what are going to be my x values that I'm going to plot is I'm going to take the period and divide it into fourths. So the period is 2 pi over b, the absolute value of b. Well, that's the number in front of x. So in this case, it's going to be the absolute value of 1. All right, not this number, that's the amplitude. All right, so 2 pi over the absolute value of 1. So our period is just 2 pi. I'm going to divide that into fourths. So 0, pi over 2, pi, 3 pi over 2, and 2 pi, just like before. And now we'll just plug the number in. Okay, we're going to plug 0, sine of 0, if you look at your unit circle, sine of 0 is 0, times the 2 out front is 0. Sine of pi over 2, we're going to plug pi over 2 in for x. Pi over 2, sine of that is 1, times 2 is 2. Sine of pi, look at your unit circle, that's going to be 0, times 2 is 0. Sine of 3 pi over 2, our next x value, 3 pi over 2, it's negative 1, times 2 would be negative 2. And then the sine of 2 pi, put 2 pi in, look at your unit circle, it's 0, times 2 is 0. All right, so we're still going to have pi over 2, pi, 3 pi over 2, and 2 pi. So at 0, it's still 0. Now, the difference between this graph and the sine x graph is this graph is just taller. All right, at pi over 2, we have 2. All right, just going through this, at pi we have 0. 3 pi over 2 we have negative 2, and at 2 pi 0. So that 2 out front increases the amplitude. It just basically makes it taller. so the amplitude, the absolute value of 2, which is 2. We have a max. All right, the max is 2. The y value is 2. That occurs at 0. Or excuse me, that occurs at pi over 2. The x value is pi over 2. Our min occurs at 3 pi over 2. And that is negative 2. And then we have zeros at 0, pi, and 2 pi. All right, so our zeros, we can write that down as 0, pi, 2 pi. Now there's another way to write this, okay? Zeros occur or repeat, and I'm going to have you write this on the next page, every 1/2 of a period. So you can just start at 0 and say zeros are 0 plus, period is 2 pi, so half of a period would be pi, and then times n, and that's where n is an integer. So that's a way to, instead of having to list every 0 all the way to infinity, you can just write it like that. Just take one of the zeros. We'll start with 0. And that's a way, a nomenclature to shorten all of that. Okay, so pause video if you need to, and we'll try a different one. Okay, the next one is y is equal to cosine (1/4) x. Okay, so we want to figure out the period. The period is 2 pi over the absolute value of b, so over the absolute value of 1/4. That's going to be 8 pi. So what a smaller number, smaller than 1, if you have that in front of the coefficient x, it widens out the graph. Okay, so where a number bigger than 1 in front of cosine, which we just have 1 in this case, would make the graph taller, or a small number in front of cosine would make it shorter. A number less than 1 makes it wider. So we have a period of 8 pi. So I'm going to divide that 8 pi into fourths and make that my x values. Okay, so we'll start at 0, 2 pi, 4 pi, 6 pi, and 8 pi. Now let's plug 0 in. Cosine 1/4 times 0 is 0. So the cosine of 0, look at your unit circle, that's 1. Now let's plug 2 pi in for x. Well, 2 pi times 1/4 is going to be pi over 2. What's the cosine of pi over 2? Right? It is 0, so have a 0 there. Plug in 4 pi. Well, 4 pi times 1/4 is pi. What's the cosine of pi? It's -1. 6 pi, plug that in for x. Okay, 6 pi over 4, that's the same as 3 pi over 2. If you look at the unit circle, then you see the cosine of 3 pi over 2 is 0. And then if you plug 8 pi in, 8 pi times 1/4 is 2 pi. Cosine of 2 pi is 1. All right, let's plot this. All right, making it a little bit longer. Do your best on your page, but we've got a 0, 2 pi, 4 pi, 6 pi, 8 pi. And then we've got a 1 and a -1. All right, so we start up here at 1. We have a 0 at 2 pi, -1 at 4 pi, 0 at 6 pi, and a 1 at 8 pi. So we've got this graph that kind of looks like a bird when you were in elementary school and you were drawing those pictures, right, that had birds in them, like a lemon yellow sun. All right, some clouds and some birds. Looks kind of like that. Okay, so our amplitude is the absolute value of the number in front of cosine. Well, that's 1, so our amplitude is 1. The period we already figured out, that's 8 pi. We have a max in a couple different spots. We have a max at 0, 1. And we've got another one at 8 pi. We have one minimum. The y value is -1, the x value is 4 pi. And then our zeros occur at 2 pi and 6 pi. And remember, zeros occur every half of a period. Half of a period would be 4 pi, right? So we could say the zeros are 2 pi plus 4 pi times n, right? So that half a period, that's a half a period. That's a way to not have to write the zeros ad infinitum. All right, so let's do one more graph. This is going to be y is equal to -2 cosine 1/2 x. Okay, so our period here, and that's going to help me determine how to plot this, is 2 pi over the absolute value of a half. Right, that one right there. So that's going to be 4 pi. So I'm going to divide 4 pi, that period, into fourths. So that'd be 0, pi, 2 pi, 3 pi, 4 pi. Let's plug a 0 into x. 0 times a half is 0. Cosine of 0 is 1. Okay, if you have your unit circle handy and be looking at it, cosine of 0 is 1 times -2 would be -2. 1/2 times pi is pi over 2. Cosine of pi over 2 is 0 times -2 is 0. 2 pi times a half is pi. Cosine of pi is -1. -1 times -2 is 2. All right, cosine of 3 pi over 2 is 0. So times -2 is 0. And then let's plug in 4 pi. 4 pi times a half is 2 pi. Cosine of 2 pi is 1 times -2, -2. All right, so we plot this out. Pi, 2 pi, 3 pi, 4 pi. We have a 2 and a -2. So we start out down here. See that negative in front started the graph down. All right. At pi we have a 0. 2 pi we have a 2. That's our max. At 3 pi we have a 0. And at 4 pi we have a -2. So this is a kind of our a bit of a mountain. Goes on for forever there. So we have a max at the point 2 pi and 2. We have a minimum at 0, -2, and then we have another one at 4 pi, -2. Our amplitude is the absolute value of this number out front, a. So absolute value of -2, which is 2. we've already figured out our period is 4 pi, and then zeros occur at pi and 3 pi. So a way that we can say that would be just take the first one, pi, plus half a period, which is half of 4 pi would be 2 pi times n. All right, so right now what you're capable of doing would be homework 5.4. You can do 1 through 8. I'm going to continue this video going, but you could stop right here and do 1 through 8 if you want. So let's go ahead and turn to page 3 of your notes, and we'll finish this up real quick. All right, some of the important parts on page 3 of your notes. Okay, maximums, okay, they occur, those are your highest points, your biggest y values. And it's important to memorize, they repeat every period. Minimums, those are your lowest y values or lowest points on the graph. They also repeat every period. And then zeros, where the function crosses the x-axis, and this is also important to memorize, they repeat every 1/2 of a period. Okay, so let's find the maximum, okay, of y is equal to -3/2 times the cosine of 2 pi over 3 times x. All right, so what is the maximum for that? Okay, so I'm going to do a little more than that. I'm going to find the max, the min, zeros, the period. Okay, so the max, this is really important for you to watch this, okay? If you want to find a max or a min, the cosine or sine of any angle, all right, oscillates between -1 and 1. So it's just, if you look at your unit circle, it's just going back and forth between -1 and 1. So to find the max, you just figure out where, you just want to look at this part right here. Okay? The max occurs, and you're going to multiply, you're going to plug in two numbers, cosine of 2 pi over 3 times x. Look at 1. If all of that is equal to 1, then it's times -3/2, that'd be -3/2. If all of that is -1, the cosine of whatever that angle is -1, then so a max occurs at -3/2, right? -3/2 times -1, and that's 3/2. Okay, so that's the y value. Now we could figure out what the x value is. You know, y is 3/2. What is the x value at that? We're not going to do that on this particular problem, but we will on future problems. So the min, you're going to take -3/2. That's that coefficient out front. And when all of this is equal to 1, that gives you your minimum number, which is -3/2. So that's your y value. That's your minimum. And this repeats every period. Both of those do. Max and the min repeat every period. What is the amplitude of this? Okay, the amplitude is just going to be the absolute value of -3/2. So I could ask you that on homework or a test. And then what is the period? Well, the period is 2 pi over the absolute value of this number out front, what we call b, 2 pi over 3. So it's 2 pi over 2 pi over 3. So that's the same as 2 pi over 1 times 3 over 2 pi. If we take the bottom fraction and flip it, then that's going to cancel, and you're going to get 3 units. The period doesn't have to be in terms of pi. So the max and the min repeat every 3 units. Okay, so if you want to know where the zeros occur, the zeros occur every half of a period. So 3/2 units. All right. So I did a lot more than just find the max on that one. We found the max, the min, the period, and how often the zeros occur. Okay, pause if you need to. Okay, the next question says find the max, and we're going to find it, find more than just the max, of y equals 3 sine 2x plus 3. Now that plus 3 is outside the sine part. So our max is going to occur. Now remember, this part here, sine 2x, the most it can be is 1. The least it can be is -1. Well, we're going to get a maximum, our biggest y value, when all of this is 1. 3 times 1 plus 3, that's going to be 6. And that repeats every period, which we'll figure out in a minute. The minimum occurs when that sine 2x, that whole thing, is -1. So our minimum is going to be 3 times -1 plus 3, 0, which also repeats every period. Okay, so what is the period? Well, it's 2 pi over the absolute value of this number in front of the angle, 2. Well, that's just going to be pi. So the max and the mins repeat every pi units. All right, the zeros repeat every half a period, pi over 2 units. All right, now we could figure out the x value where we have a max and where we have a min. All right, we'll do that on one of the homeworks, but that's not a major topic, at least for this one. Okay, I'm really wanting to know what is the max, what's the biggest y value, what's the smallest y value, the min, what's the period. We also, what is the amplitude? All right, on this one. So the amplitude is going to be 3, right? The absolute value of 3. Right, that number in front. Okay, so let's do one more, and I know this is a long video, a long lecture, but you can watch it over a couple different couple different sittings. So I'm not going to write all this down. The last problem is the waves of a tsunami are 50 feet high, 528 miles apart. It takes a wave 20 minutes to complete one period. How fast are the waves traveling? Okay, so this is a distance equals rate times time problem. Very important to remember that equation. Now the distance is just equal to the period. All right. We are trying to find how fast. So rate. Well, rate is going to be distance over time. Okay. So it says that it takes a wave 20 minutes to complete one period. So that is the period. That is the time that it takes to complete the 528 miles. So you've got 528 miles. The time is 20 minutes, all right? But we can take that into hours if you want to do it in miles an hour. 20 minutes would be 1/3 hours. So that's 1,584 miles per hour. If you did it divided by 20, it'd be miles per minute. Okay, so this test coming up, you might have to make a change there to match whatever the multiple choice answer is. Okay, so for these, you just got to remember distance is rate times time, and that in this particular one, how high the wave is, that 50 feet high, that doesn't matter. That's the amplitude. That's dealing with, if it asked for the amplitude, you could say, okay, it's 50 feet. All right, but you don't need that in this problem. That does it for lecture 5.4. You can finish the 5.4 homework. All right, if you stopped at the middle of this video. And I will talk to you next time.